On behalf of nocoalinoakland, welcome everybody. We've got 40 folks on participating, and I see lots of people who have been part of our campaign and people who haven't seen before. So I'm Laura Jofu. I'm a member of the nocoalinoakland coordinating committee, and we have a stellar panel of scientists who conducted a study monitoring coal trains as they traveled through Richmond and coal piles sitting at the Levine terminal, all the while spewing fugitive coal dust into the community. The scientists will speak about how this study came about, how they created the monitoring technology, the results of the study, and the impact on the health of residents exposed to fugitive coal dust. Let me introduce our speakers. We have Bart Ostro, who for 26 years was the chief of the air pollution epidemiology section of the California EPA and currently a researcher at the UC Davis Air Quality Research Center. We have Dr. Heather Kuiper, who is an independent public health consultant in research, planning, civic engagement, and leadership with national and international experience in a range of disciplines, including environmental justice, climate change, and reproductive health. And finally, we have Dr. Nick Spada. He's a scientist with the UC Davis Air Quality Research Center and co-director of the Citizen Air Monitoring Network in Vallejo, California. His work focuses on understanding the prevalence of human-made pollution in micro-scale environments, such as mixed urban industrial communities. So welcome our scientists, and we'll turn it over to Bart.
First of all, I wanted to thank Laura Jo and Margaret and Janet for organizing this and for inviting us to present our results. And I also want to thank volunteers who might be in the audience, and given that it's recorded, there's going to be some volunteers who aren't in the audience who've played some role in all of this. We've had a lot of help, not only within communities of Oakland and Richmond, but in California and actually other places all around the globe. We've had conversations with multiple dozens of individuals who have provided review and insight. So it's been truly a group effort. So I will start with basically, trains transport about 70% of coal deliveries in the United States. And the amount of coal dust that is lost in uncovered coal trains is significant, sometimes up to 3% of the total amount of coal. And it's actually been stated by some of the train industries themselves about the dust from the trains. These emissions produce microscopic particles, PM 2.5, that you've probably heard of. These particles they get inhaled into the deep lung and can cause systemic inflammation. And there's no known safe level of exposure. So that goes down to very, very low levels of concentrations, and health effects have been observed. Also, the particles will disperse widely if there's any kind of wind or even very little wind. So exposures can increase into the community with health effects, including anything as severe as premature mortality, all the way up to or including things like asthma exacerbation, hospitalizations for emergency respiratory and cardiovascular outcomes. And now there's evidence even of things affecting or exposures affecting cognition, things like Parkinson's disease and others. So there's a lot of new evidence coming up almost every week on the effects of particles. In addition, besides the trains, the storage and conveyance of the coal at the terminals and near the terminals often occur near economically disadvantaged populations. So there's exposures from that route as well. And despite all this, there's been no study to date in the United States on effects on the urban population. Laura Jo asked me to maybe give a little bit of backstory into how we got involved in all this, so I will get into that now. A developer in Oakland proposed shipping 10 million tons of coal to a new port facility in West Oakland. And I'm being very brief here because we could spend days just going through everything that happened. Oakland passed a bill, City Council passed a bill unanimously to prevent shipping of coal based on health concerns. It went to court, and Judge Chabria ruled that the Oakland City Council didn't have, quote, substantial evidence indicating that shipping millions of tons of coal through the city would endanger public health. And that's, even though we wrote a report that Heather organized, a public health advisory panel that indicated there were likely health effects, that was not conveyed in an appropriate way by the lawyers and wasn't really considered strongly. But there's only been one study in the US measuring coal from trains. That's a paper by Jaffe et al., which we did cite in our own work. But that was based on Powder River Basin coal in Wyoming and conducted in rural Washington. And the judge had ruled that Powder River Basin, which is subbituminous, is dirtier than the coal from Utah, and he didn't think it was relevant. I thought it was, but he did not. So the judge ruled against the city. Over time, this decision that you see was in the papers in mid-May. Over the next couple of months, I thought about, it's pretty amazing that given that coal trains go into urban areas all over the country and all over the world, that there hasn't been studies on its urban impacts. And actually then about 6 weeks after this hearing, I woke up at 3 o'clock in the morning and I got an idea, which was where most of my ideas come at that time. Got an idea that we could actually use Richmond, the terminal there, the Levin terminal, to study what kind of particles, if any, would come out of the trains. And Richmond was a perfect case because they are also getting coal from South Central Utah, the same place that Oakland was, it was proposed for Oakland. The same train lines would be used. And there was a lot of good reasons to use Richmond. So I talked to Heather a couple days after that and asked her about it, and she thought that was a great idea. And then through a third person, I accidentally met Dr. Nick Spada, who is an engineer with Davis and is in charge of some of the national EPA networks, monitoring networks that exist. And it was a total accident that I met him, and it's actually a funny story how I met him, but I won't get into it now, given we want to move ahead on time. But he was doing some monitoring in West Oakland and was very into environmental justice issues, and he said, sure, let's do it. So the three of us set about starting something in 2018. We figured we'd do pro bono work. We just get the work done ourselves. Nick would put together some monitoring equipment at UC Davis, and we'd go out and start monitoring coal from the trains heading to Richmond. We soon realized, we set up a practice site up in Hercules near a train station and or near the train lines. And we soon realized that our efforts would not be satisfactory, wouldn't pass muster, and we really wanted to up our game. So we then decided to apply for our Air Resources Board 617 Community Monitoring Grant. We received the grant in March of 2020, and then we could really begin doing our work. So we needed to find locations that would work. Specifically, we wanted to have a location near the train line in Richmond that was not affected by a lot of the other sources of particles, of which are many in Richmond. We couldn't have someone sitting around waiting all day for a coal train, which is what have stopped people in other countries that I've talked to from doing this work. They didn't have a way to actually visually identify coal trains versus other trains for weeks or months at a time. And we didn't have we needed a safe place for equipment. We needed the monitoring. We needed meteorology measurements so we could control for wind and humidity and other factors. We also wanted to be able to observe coal trains at nighttime, since some of the trains come in at night. So Nick was able to develop, using artificial intelligence, a technology that's unique to identify, as they're moving, either full coal trains, empty coal trains, passenger trains, or freight trains in real time. And this has been a major factor in our project. And in fact, we wouldn't have a project without it. So that's how we got involved with all this. And I thought you might want to see Nick in action here with his train set. It wasn't a train set he was building for his kids for Christmas. It was a train set to test how well the cameras would observe the trains as they were moving and how to deal with the technology. Here's a close-up of that beautiful train site. I think, Nick, you should have put some more trees in there and so on, but it is what it is. Finally, we actually had the Santa Fe Railroad here. So a little mini copy of that. So this enabled us to do this project, basically. And the technology that Nick worked on for 1.5 years, 2 years to make this happen was amazing. Had to happen during the COVID epidemic, when parts were not available a lot of the time. There was a lot of workarounds. There were supply chain problems. We couldn't meet in person a lot of the time. But through the perseverance of all of us, but particularly Nick and his staff at UC Davis, the students, we were able to make really good progress. And in 2022, we started measuring the trains as they were passing by our observation site. So the key questions that we wanted to address were, using the Richmond, California site, do coal trains contribute to PM 2.5? And there's an asterisk there to remind me to say, and are the increments different from freight trains and passenger trains? Then there's holding yards. We're storing coal trains and freight trains. Do they contribute to PM 2.5? Do the terminal operations increase coal and petcoke particle exposure in the surrounding communities? And finally, our subsequent health effects anticipated. So this was our goal there. So I'm going to first talk about the coal trains that were passing by. And this is the one that's been published in an article in a peer-reviewed scientific journal, international journal. It was published in February. And I think in the notice, the article was cited, and you can probably pick it up. I can't go through all the results, of course, but I can. I'm going to try to cover some of the highlights. So the coal trains were observed between May and October of last year. We found a site near the railroad and one clear of other PM sources, and I have a map on the next page that will show that more clearly. We had the device that was developed had motion detection, so that when the trains came on, everything was, all of our measurements were turned on. As I mentioned, it had the AI recognition camera to record and differentiate passing train types, and we had 4 different types of trains, as you can see listed there. Our system also had infrared light to identify the trains. At one time, we had a big light, and that didn't seem to work that well when we were in Hercules. And infrared light measures the heat and can detect the trains as they're coming. And it also allows us to see the trains at night. Regarding our specific pollution monitor, we used something that similar to purple air, use the guts of purple air. But when purple air is recorded on its website, it uses one of the channels that actually has 3 channels, 3 different measurements. And the EPA protocol suggests or indicates that you should look at all 3 channels. And if there's some outliers, get rid of the outliers, but you should use all 3. It's way more robust. So Nick spent many months testing the system, calibrating it, measuring it, and make sure that we could get real-time streaming measurements of the PM 2.5 meteorology. And meteorology is important because you want to make sure that you have the wind patterns, the wind speed, and also humidity. They're all important in there, and I'll explain why in a few minutes. So our sample ended up not as large as I would want, but with enough power to detect what we needed to detect. We had 15 full coal cars, 14 unloaded, or we call them empty, but they're just unloaded coal cars, coal trains. And again, due to the low economic activity, that hurt our sample size. Reason we looked at unloaded is because there was one study in England, only 2 days of observations, but they found in their study that, Australia, they found that the unloaded coal cars actually put out a lot of particles, and in some cases more than the full coal. So we thought we would look at the unloaded as well. So once we had all that, then we wanted to calculate the increase in the average concentrations of PM2.5 from the passing train. And by the way, I should mention, for those who are not familiar with this, coal trains typically are a mile long. There are 100 to 130 trains on each passage, and they're pretty impressive. So we looked at the average PM2.5 from trains versus a control. And what the control means is we want to know what the concentrations are prior to the train. And other people have used or could use train controls like background monitors and all, but this is really the best control to look at the concentrations right prior to when the train is passing. It's really almost a perfect control. And again, I'll go over that again a little bit more. Then we use multiple regression analysis, which is a statistical analysis that allows you to look at the primary thing of concern, the trains, but also to control for other factors at the same time, like some of these weather factors and the train speed and so on and so forth. And so we did that. And then we also did multiple models of this by looking at different covariates, different things to control for. And this is important to ensure that the results, you don't just run one model and get a result by chance. You want to run a lot of models, and you do what is called sensitivity analysis. So all of those models are included in the paper if you choose to look at them. So was our monitor site, and there's a train line. The yellow is the train line. The site was 80 feet from the midpoint of the train line. And you can see to the west is just the bay. This is all open space, and there's a park trail here. And to the east is a golf course, and no major roads are here. This is an example of a detected coal train. The infrared makes the colors pinkish reddish here. But this was our observation point for the trains coming from Utah along the Carquinez Strait, right down along the coast through a bunch of cities, and then down into further down into Richmond terminal, which is the 11 terminal, which is not on this map. So we were lucky we found people who are willing to host a site there, and we went from there. So again, just so you understand what our calculations are, for every train that comes by, there's a control period, which is a 10-minute average of PM2.5. Then we have a 10-minute buffer. And we had a buffer because, as the trains come, they push the air in front of them. If you've been in a subway station or even train station, you know that there's a big huff of noise and pollution that comes out minutes before the train. So we had a 10-minute buffer period. And we looked at a lot of different averages of buffer and pollution, of control, of averaging time here for the control. And it really didn't matter. We looked at 5-minute buffer with 2-minute average and all sorts of combinations, and it all came out about the same. So once we do this, it's a perfect control because you know exactly what the concentrations are right before the train comes, and then you're measuring the train. So you don't have to worry about the day of the week where particles change all the time, weekdays, weekends, the time of day, there's diurnal patterns in particles. You don't have to worry about that because we actually know what's happening right before the train. So it's a really good protocol. So what did our results look like from all of this? Well, let me show you this as well. So let me just stop this for a second. So this is showing how Nick's, part of what, how Nick's protocol worked. And this is a graph here showing, we're going to show the three sensors. I'm going to let it go now. And the train moving, we knew the wind direction. This is just a little cartoon of where the monitor was and where the train was. But you can see now the particle concentrations growing from all three channels as the train passes. This happens to be a freight train here, but as the freight train passes, you can see what's going on here. So I'm going to stop that now, and in the interest of time, and then get into the actual results from our regression modeling. So it's important to note that these are 5-minute averages of the trains. The trains take on average 4 to 5 minutes. So these are basically 4 or 5 minute averages. And so the exposure difference is different than what EPA does or what we all do as epidemiologists when we're doing health studies. We usually the data are available for 24-hour averages or annual averages. There's not a lot of studies based specifically on 5-minute averages, but with repeat trains, the 5-minute average becomes an annual average or an hour average or a daily average. So there are studies looking at exposure periods as short as 1 hour. So these are still relevant for health effects, but I just wanted to make sure people were aware of the averaging time, that these were not annual averages yet. They might end up being annual averages, but they're what our study was looking at was 5-minute averages. So here's the very basic model where I just had the speed of the train and the wind speed coming towards the monitor, or not even towards the monitor. Some winds were from other directions, but the wind speed measured near the monitor. And passenger trains were so fast, about 65 miles an hour, and so quick. They were literally 5, 10, 15 seconds by. So we ultimately didn't really see much from them and didn't include them in any subsequent analysis. But we did have empty coal trains, freight trains, and full coal trains. And here you see in the basic model and these are micrograms per cubic meter. It's a measurement of mass of fine particles of PM2.5. It's a standard measure used all over the world. And to give some perspective on what these numbers mean, World Health Organization now has a 24-hour standard of 10 micrograms and an annual average standard of 5 micrograms. So this gives you some perspective as to what these numbers mean. So a full car, no top to it, about 7 and change micrograms per cubic meter, about a little over 2 micrograms higher than the freight train. And then, like I said, I looked at many, many different models. This was and I want to pick out a couple interesting models here. So this is a model with calm winds. And what we think happens is with wind, the particles get dispersed to a wider area. When the winds are very calm, the monitor that's really close to it, about 80 feet away to 100 feet away, will get more of an impact of what's happening there. And you can see that that's what happens here. The freight train doesn't change, nor does the empty train. But the full coal cars now put out about 12 micrograms per cubic meter. And as I note down here, it's a lot to read, and I can just tell you that there was 3 cases when we had calm winds and winds from the west. So you would really get a focus on our monitor. And in that case, we had an average for the 3 cases that we had of 25 micrograms per cubic meter during that 5 minutes. So a big change for the full coal cars. And again, the freight cars did not change very much. So pretty strong evidence, in my opinion, of a significant contribution of the coal cars. And then finally, this third case is our calibration model. And the reason we have to calibrate, and none of these models are perfect, but taken together, I think they're very, very convincing. We calibrate because the federal reference method, the federal method for monitoring fine particles is a mass-based. They collect the mass of fine particles. And the system that Purple Air uses is based basically on optics. It's an optical measurement. It measures the blackness, the darkness, or the light that comes through. So if you remember during the fires, the big fires, wood smoke was there, and wood smoke was very black. And Purple Air had a correction. I don't know how many people use that correction, but it had to correct the concentrations because they were blacked. So there's been studies that compare the blackened concentrations to a federal reference method. And that's what we used. We had a federal reference method about a mile or so away from our site, and we could correct the blackness and convert it really up to a better measure of mass. It's not perfect. The fit wasn't perfect, but it was reasonably enough to be used. So you can see with the calibrated monitor, the full co-car still put out more than the freight, again, around 2 micrograms per cubic meter more than the freight train or the empty co-cars. So taken together, and again, you can look at the other models in the paper. We always saw full co-cars higher than freight trains in different levels. By the way, this calibration also controls for humidity. So, and I controlled for humidity directly in some of these other models down here. But this model, when it's calibrated, directly controls for humidity. Why do you need that? Because in more humid areas, more humid times, the particles take on, they're hygroscopic, they take on larger values. They get bigger, big mass. So you want to control for that. And that's what this calibration also does. So it controls for the humidity. So another thing we did as a way of maybe checking our work is we compared our study to the only other study out there, the Jaffe study, which I mentioned. He only measured 10-second max, the peak of 10 seconds of the coal cars and the freight cars. So we did that, and we found, I think, amazingly similar concentrations. Ours for 10-second max, the average was around 17.4. We used the same methodology with the control, the buffer, and then the measurement, but this measurement was looking at the 10-second max. And you can see full coal cars were pretty similar, and the freights were pretty similar. His were a little higher because he is looking at dirtier coal and faster speeds. So we also looked at the holding yard, and both the passing trains and the holding yard are very relevant to Oakland, because both Oakland and Richmond case need both of those things, of course. They're having the trains come down and they need a holding station because you can't have 100 cars lined up right at the terminal. So these two areas are very relevant to Oakland's case. We did the monitoring in 2 different periods. We monitored, the monitor site was 70 feet from the holding yard. We used a camera. We didn't need the AI for this. We used a camera to record what was there in terms of trains. We used the same monitoring system. And we had hourly observations in this case, and we had over 1,000 full coal cars over 200 days of observation. That means some days had multiple observations. So our statistical analysis used what's called a fixed effects analysis, which controls for the fact that you have multiple observations in a single day. So it takes that into account. So again, we used the 1 hour average in this case, not a 5-minute. And instead of looking 10 minutes before, since the trains weren't moving, they were sitting there, we looked at the background monitors, which I'll show now. So here was the holding area. Here's the terminal. And we had a bunch of control sites down here. And then we looked at the difference between what was measured at the holding sites and measured down here from the different types of trains. And you can see here, again, it's a 1 hour average. And basically we found about a 0.2 microgram difference between the full coal trains and the empty trains and the freight trains. When we had lower wind, again, the levels were much higher, but still about a 0.2 microgram difference at the holding stations. The third thing that we did was look at community exposure to coal and petcoke from terminal operations. Again, we measured over a 2-year period, not every day. There was some technology issues along the way, but this is pretty interesting stuff. We put passive monitors at 5 community sites and analyzed, and these were provided and analyzed by an independent lab called R.J. Lee, very highly regarded. They actually worked on the International Space Station. And they used scanning electron microscopy. And what does that do? Well, that shoots electrons at the subject, at the device, and it interacts with the atoms and then creates a signature so you can identify what you're looking at by size, shape, and chemistry. So just as so it's able to look at a single particle, and in this case we were able to look at single coal particles and determine their concentrations. The second device we used was surface additive tapes at 4 locations to corroborate what the independent lab had done. We had 4 locations, 2 that were the same as the lab and 2 other ones, and they were analyzed at UC Davis at the Crocker Nuclear Lab, again using scanning electron microscopy. The scanning device there has been used to verify the Dead Sea Scrolls, the Gutenberg Bible, and thousands of other things, because they can look at things at the molecular level and determine how old those things are, what the chemistry is, and so on. Pretty amazing, if you ask me. Then we also sampled particle size and species near the terminal using a drum sampler, using a Davis sampler. So let me quickly go through the results here. These numbers are the concentrations of coal or petcoke particles, or coal and petcoke particles. And you can see, again, here's the terminal, pretty high concentrations of fine particles, 0.6 here and 0.6 here. As you move into the community, concentrations get smaller, not surprisingly. We also looked at coarse particles, and there's a lot more coarse particles coming off these trains, the bigger particles. Coarse particles are the difference between PM10 and 2.5. And you can see near the terminal, 18 micrograms. And again, as you move away, the levels get lower, but quite significant impacts into the community. Okay, and then here's our tape samples. You can see actual coal particles that were picked up on our tapes. And this verifies some of the locations that there was coal, and including Parkchester Village, where our train bypass monitor was set up. So coal was observed in these areas as well. And finally here, this is too long to explain, but the yellow here is coal particles. These are more combustion particles, but these are coal particles here. And they're relative to the holding area, not the holding area, but the storage area for coal. You can see it's to the northeast, and that's what this shows here. So there's coal observed through the drum samplers at Davis. Another confirmation that there's coal in the community. So fine particles, are very, very small. I won't spend the time going in this. They're about 1/40th, 1/30th the width of a human hair. As I mentioned, they penetrate deep into the lung. There's a whole range of serious health effects. Every week there's new effects that are observed, including, like I said, neurodevelopment in children, birth outcomes, and some of these cognitive effects, and then the big cardiovascular and respiratory effects, and a lot of cancers. We used to think it was only lung cancer, and now more cancers are showing up. And then I want to just, again, indicate that most studies have used exposures of days or years, most of our studies, but we did find a series of studies that looked at 1 hour or multi-hour exposures. And here's a list of things that were found, including heart disease, heart attacks. So that means there's some likely mortality as well as emergency room visits for these diseases. So there probably is mortality here, and other things like work loss, school loss, asthma, and all that are also very likely. So our conclusions were that coal from trains, holding yards, and terminal operations in our study increased ambient PM 2.5. I should say significantly increased it, and the increase was greater than freight or passenger trains. We also found evidence that the associated particulate matter reaches residential communities. And by the way, there's studies on both PM2.5 and those coarse particles that I mentioned, particles that are between PM2.5 and PM10. There's a lot of studies on coarse particles, including mortality and a whole range of diseases as well. And finally, the levels of exposure are enough to cause important health effects because there's no known threshold for most of these studies. Most of the studies go down to the lowest levels. There's studies in Canada where the lowest levels are 2 or 3 micrograms, and you see the same effects that you see at 10 or 20 effects. The risks move up linearly as you go to those higher levels. So as I indicated, there's no safe level. All the contributions to particulate matter and exposure are increasing risks and causing health effects. So I think I will stop there, and we can open up for questions.
Thank you, Bart. So we'd like to invite people to write questions into the chat, and I'll start with one that came in earlier. The question was, to what extent are freight train emissions attributable to the engine burning diesel? So that's with regards to the freight train.
And the answer would be there's clearly diesel that's contributing to that, and there might be a little dust coming off the freight trains as well, but for freight trains, it's primarily going to be diesel. Now, a lot of the diesel is very small particles, way smaller than, they won't even be counted in PM2.5. They're ultrafine particles, which have basically no mass, so they won't show up in PM2.5. So it's likely that there's some other fugitive dust coming off the freight trains.
And there's the issue of re-entrainment. The significance about coal coming off of coal cars is that it sticks around and gets kicked up again when other trains go by.
That's right. In fact, the trains a few years ago indicated that they were concerned about coal on the tracks because it could degrade the tracks, and believe it or not, cause derailments. So as Heather has indicated, yes, there would be concern just for the coal. It's there over time and gets re-entrained. And it could be that the freight trains are just re-entraining because they're really long and fast. They could be just re-entraining the coal.
Yes. Okay, so another question. There were a few questions about empty cars. One, just for clarification, was a question about why would empty cars be going to the terminal? And just to clarify, the empty cars, part of how we could detect them is that they were going in a different direction, and we captured that direction and wind dynamic as well. So then the question is, were you surprised that the empty cars contributed less particulate matter than the full cars given other studies? And how do you know that that particulate matter increase when the coal cars came by your monitors were only coal particles and not also dust kicked up by the moving train?
Okay, well, the first part is, can you repeat the first part again? Sorry.
were we surprised about the empty cars?
Okay, yeah.
contributing less
Yeah,
particulate
let me do that
matter?
one. So I was actually surprised that empty cars were putting out much particles at all. And again, there haven't been a lot of studies. There was this one study in Australia, New South Wales, that showed big effects. And I talked to the author and I expressed some surprise, and he said, you know, that they're loose on the bottom, so maybe they're more easily dispersed out of the cars. So I don't know if there's a great hypothesis there and on exactly why, but it has been seen. Now, the other question is, the other part of that question was,
how do you know that the particulate matter is related to the coal and not other dust also kicked up by moving trains?
well, it's probably, I mean, it's, you can't rule out other dust. And there have been a few studies where the areas next to the tracks have been measured. The dust next to the tracks have been measured, and the coal can make up 20 to 40% of the total dust. So I'm sure there's other dust kicked up by that.
Yeah.
But go ahead.
Oh, well, this is where our design is so important. So we had several strengths to the study, including this AI detection and use of infrared and the 3-cylinder monitors to improve data quality, but also being able to distinguish the different train types really allows us to look at the delta or the difference between a freight train and a coal train. And that's why we can really, with some confidence, isolate that the additional particulate matter that we're detecting is related to coal, because you would think if it's just dirt, then it wouldn't be any different from freight trains.
Both the freight and the coal trains would be kicking up whatever's there. The coal trains
Similarly,
kick up a lot more.
right. And another design issue is that with the train passages, we picked a location that specifically was not impacted by other pollution sources, in particular the freeway. Anyone who's been working in Richmond knows that the freeways are always cited as, well, that's the real cause of the pollution. So our location eliminated other possible explanations for particulate matter being from other sources. Okay, so then Nick, you might want to jump in. Someone wanted to, Janice asks about asking more information about the 3 different channels in the monitor, and she wondered if those were based on the size of the particulates or what the other function was that we want to describe. Would you like to describe that?
Yeah, absolutely. So this is not separating by particle size. These are 3 laser devices. So it's actually 3 individual measurements of PM2.5 that we wanted a really robust estimate of the PM2.5 in real time. And so by using triplicate measurements, we could calculate the uncertainty of each of the measurements because we're collecting at 1 second. And then also the redundancy, so that in case one of the sensors went out, we would still have 2 that we could rely on to average.
Thank you. Okay, so moving right along, there's another question about what type of measures were in place at the terminal to reduce the coal dust from the exiting empty trains? And was there washing of dust into the bay using water? So I might say, and Bart and Nick, you can chime in, that I think that was beyond the scope of our study. So we did not detect activity along those lines, and we didn't really look at water impacts. I'm glad that you're raising that, because this is a whole nother area of potential impact that we have not focused on and yet still matters. We have a question here. I believe it is Lincoln Elementary, where teachers wrote a letter about wiping coal dust off their classroom windows every day in Richmond. Is that right? That might be for community members to answer. Maybe wait till the breakout room for specific.
I think we had a site. Didn't you have a site there, Nick? That was.
Oh, okay, yeah. Thank you, Bart. Go ahead, Nick, if you have.
We didn't have a site, but we went and collected a tape sample from a sign right by the school.
Yeah.
And you found.
Yeah, and there was coal, petcoke,
Yeah.
dust on it.
Right. So another question, is it fair to conclude that stronger winds blowing eastward carried some particulate matter beyond the monitors? The question, if I understand it correctly, is really about the impact of strong winds on our findings versus, what, like we saw really high levels of particulate matter when the winds were calm. And we did have some conversations about what might be happening as he describes that just blowing past the monitors.
Yeah. If we had more data, we'd probably, I'm guessing we'd see a U-shaped curve with the wind. So when things were very calm, our monitor would pick that up nicely, as I indicated. And when the winds were heavier, there's going to be more dispersed, but there's going to be more coal coming off the trains. So there's a balance there, and it's unclear how that ultimately goes. But I think we found, in general, when the winds were stronger, we found higher concentrations.
Mm-hmm.
So, but it really depends on where the monitor is located and the direction of the winds and so on and so forth.
Right. So we do think that those stronger winds, that the impacts might be greater than what our study detected because of the dispersion. So let's see, does particulate matter, or specifically PM2.5 from coal dust, accumulate, or does it disperse and settle quickly? I think that might mean accumulate in the air.
Well, fine particles are known to stay aloft for long periods of time, between hours and weeks, because they're so small, they're so fine. In contrast, coarse particles are even larger than coarse particles. As they're heavier, will tend to drop off closer. That's probably why we saw the 18 for coarse particles near the terminal. But yeah, fine particles will can last a long time, depending upon the atmospheric conditions and the wind and so on. The mixing layer, what they call the mixing layer, and wind speed will all determine how long the particles will stay in the air.
Mm-hmm. So we have some questions about petroleum coke, and wondering if we have any guesstimates about what portion of the load that we measured is accounted for by petroleum coke. And one of the questions is about from the coal trains, and I just wanted to perhaps specify that what we'll answer about is really about that other part of our study, which was measuring terminal operations, because the petroleum coke was transferred by trucks to the terminal, and we didn't track truck activity specifically. Our terminal operations measurements account for all of the activities, coming and goings of trains, trucks, storage and handling at the terminal site. But our other component, for example, at Parchester Village, where the train went by, that was just measuring coal train, and we wouldn't anticipate petroleum coke being in those samples. But Nick or Bart, would you like to make some comments about the petroleum coke coal proportions?
Yeah, I can start, and Nick can add. In the RJ Lee analysis, they were unable to yet specify the differences between the petcoke and the coal in that sample. And I know Nick is working with them to try to get that resolved over time. So we can only make a qualitative suggestion as to what's going on. And in 2018, there was almost 1 million tons of coal shipped to Levin. Now, 2/3 of those usually get loaded on the ship in Stockton. So 1/3 of those will come by train. That's all approximate. So that means about 350,000 tons of coal, and there was about 250,000 tons of petcoke. So you might think, and then given the trains, the activity of the trains and so on, I would guess that it's more likely that the majority of that is coal, but it's really just a educated guess at this point. I mean, it could be 50-50, but I'm thinking it's going to be more likely to be coal, given that in the terminal operations. And Nick, do you have thought on that?
Yeah, I think that's the best estimate that we can give right now. In looking at the particles one at a time, a lot of the particles are very easy to tell the difference between coal and petcoke. Petcoke are very glassy, angular, jagged particles, and then the coal is much rounder. It has aluminum silicate particles embedded inside it, but not all the particles were dissimilar enough for us to give a fully quantified answer to that question yet.
And then also an observation that empty coal cars have been seen on the Union Pacific tracks going from the terminal stretching up to 1.5 miles long, maybe 2 miles. And it is true, we measured one holding yard site, but coal trains are stored in a variety of locations in that area, which probably is typical practice at export terminals. And so that would be another way that our study underestimates, what the actual community impacts are. What we've been able to do is really have proof of the emissions and proof of exposure, but the extent of the exposure is not something that we have finalized for this study. Bart or Nick, would you like to say anything about kind of additional sites?
No, I think yeah, I mean, there are other sites where there's holding areas, and yeah, we didn't measure those, that's all. Yeah. They're probably another source of particles as they go back to where they came from. So, yeah.
Yeah.
It'd be interesting to look at those.
Yeah.
Actually.
And on the topic of underestimating, another way that our study is likely underestimating full exposure is because we really focused on fine particulate matter. And as Bart pointed out, coarse particulate matter and also ultrafines come along with these emissions, and those were not measured in this study. So let's see, some questions about terminal practices, and just again to say that we were not specifically monitoring terminal activities. And so we don't know about their practices with, for example, washing out cars or their facilities. Let's see, are we sharing our study data with people who study the Bay? Where are we at with our collegial exchange, Bart and Nick?
With other researchers, so I've been in touch with other researchers. I've not gotten to the point yet to offer to have Nick travel to those places and spend a month setting up their equipment, but there should be more interest in that for sure. Yeah, and regarding the, I see another question here about the empty cars.
Mm-hmm.
Somebody indicated, well, maybe Ted, maybe the cars are different there in Australia, and that's possible. Maybe that's why they had differences or such a strong effect of empty cars. It's hard to know. Yeah.
I'll just comment that the plan is to share the data it'll be public, and we're very happy to work with other researchers or people who want to understand this better. Absolutely.
Yeah, along those lines, Nick is already involved in some really exciting community-based work with the technologies and algorithms that have been developed through this study. We think that in addition to the coal issues, there are real contributions from this study to the general enterprise of mobile and episodic event monitoring. So he's getting launched in those areas as well with work that was achieved during this study. And then we've had interest from around the country from what has been detected here and the methods used. Would it have been feasible to model the effect of passing trains en masse without using fixed effects? My experience with fixed effects models is that they have a significant downward bias in the measured response. If there's measurement error in the independent variable, which I assume was present during due to the small sample size. Whoops, sorry.
Yeah, I could look up the paper, but my recollection is the effects were pretty similar using the fixed effects model or not. They weren't drastically different. So you could feel better about that.
Yeah, that's my recollection as well. And let's see, are swipe samples from window ledges, which are protected from rain by an overhang, a good method to take accumulated coal dust samples if the house, sorry, if the house is closest to and facing the coal trains?
So Nick can take that one, yeah.
Yeah, I'm very curious, so I pick up dust samples pretty much everywhere that I can find them. A ledge is a really nice pocket that collects dust, as any of us who, clean the outside of our house like that. Yeah, but it would accumulate dust, and taking a tape sample from there. Charles, I can connect with you later about the carbon tape that I use. It's simple graphite tape, and that lets us do this single particle analysis. And then, but the sort of an official method to collect surface samples requires a 1 foot by 1 foot square. So collecting from a ledge isn't sort of a defensible sample, but it will be informative. But we can, I'm happy to, talk about that more.
Yeah, you got to be really careful about, as Nick is indicating, how you do it, how it's documented, how it's preserved, and so on and so forth. There's a lot of steps. I mean, if you just go and wipe something and say, oh, I found something, that's not going to hold up anywhere.
Right.
But Nick can guide you, or you can check the literature on how to do it. But it's important to do it the right way, or else it's not worth the time.
Yeah. So let's jump back again to some of the pioneering technology developed in this study. Are there other researchers looking at the technology that was devised in this study? Tell us more about the AI camera and how that might be being used, or what interest there is in its application to other questions.
Yes, so I'm talking to Chris Heaney. He's at Johns Hopkins. He's studying the coal terminal over in Baltimore. It's a huge coal facility. They've been having a really tough time monitoring it. They can't get close. And it's a similar situation, and they're really excited, to be working together. And so, yeah, Curtis Bay facility, exactly. And so we're starting to work together so that we can apply this technology and these methods for their work as well. One of the really neat things about it is that it can identify all kinds of different objects, not just trains, but we can look at diesel trucks or marine vessels, or we can even use it at wildlife refuges and look for the endangered species. So searching for, endangered butterflies and things like that. So anything that you would have an undergrad sitting out there with a clipboard, this can do it better and easier.
Now you have the undergrad sitting at the keyboard training it.
That's
right. It's debatable how much work or which one's easier.
Nick, there's one or two more questions here, and I wanted to go back to one about household air filtration. But before that, just on the topic of AI, just because it's exciting and, all the rage right now also, can you tell us a little bit about the process of how you train those and how many images you went through? And it's pretty impressive, and I bet this group would be interested to hear.
It's actually fairly similar to training a toddler their ABCs. So the first step is to collect a lot of images of trains in each area. And so we set up the cameras, and they just collected images every single minute, round the clock. And then we collected many, many images. We sifted through 1 million of them and categorized each of them. So that was a lot of work. So we sort of created a little video game out of it. And we could process, 4 or 5 days at a time, thousands of images at a time. And then once they were classified, then we give them to the computer, and we were sort of piggybacking off of Google's work, using one of their AI models to classify images. And so we retrained Google's model so that it could look specifically for trains at the specific locations that we were monitoring at. And that was how we were able to teach the computer to see when a train was coming by. So then the next phase was when the computer identified that a train was there, it started a recording. And because we wanted to capture the entire train event, we didn't want to lag or anything. We actually had a buffer of the video going so that we captured a whole second before the train arrived, the entire train event, and then a second afterwards, so that When we reviewed the data afterwards to, verify that the computer was doing what it was supposed to, and then to check the train types as speed and direction, we had the entire event to look at. So we looked at over 3,000 videos of trains day and night, all kinds of different trains.
And something like 1 million frames, right, in that process?
A million pictures. Yeah, we classified 1 million pictures.
So, and if a picture speaks 1,000 words, we're talking.
Yep.
I wanted to add that the positive identification of daytime trains was about 99%, maybe 100%, but no one likes to say 100%, but it was 99%, and nighttime 97% confirmation. So that's pretty amazing. And this is only Nick's 4th job that he's doing. He's doing 3 other jobs. So he really made a major effort on this project. I also wanted to say one thing about Baltimore, which is that we have been in contact with them. We had a couple conversations with them a few months ago and gave them some suggestions. And of course, they didn't. The lawyers we talked to in the community doesn't have the funding for monitors and so on and so forth. But they were thinking of a GoFundMe, or I suggested the local county health office, but so I don't know where that's gone. That was about 3 months ago that we talked to them, but we did try to give them some advice.
So bringing it on home, there's a question about if home air filtration or HEPA filtration in homes can clear the air from PM 2.5.
Yes.
Great.
Does a great job.
About 97, 98% effective, I think.
Yeah. Janet makes the point about the EPA's focus on environmental justice, and this is a good time. And it's good time to have that money converging with the technologies that are developed in this and other studies. And in fact, that's one of our recommendations. We've just finished up our comprehensive report, and we'll be sure to send that out. So what you've had access to thus far is our peer-reviewed journal publication, and we wanted to get that out as quickly as we could because the findings were there and ready, and we know that it's of immediate relevance for these communities. But we have a comprehensive report that covers what Bart talked about today that goes beyond the train passage to the holding yards, the terminal operations and community exposures and health implications. We have not quantified health impacts at this juncture. We are looking into the possibility of doing that. But we do have a good profile of Richmond's community, and so that health implications can be commented upon based on our findings. So let me just say in conclusion, so we'll make that comprehensive report available. So I think that's about it, and time for the breakout groups. We really appreciate the opportunity to share our work with such an engaged group of citizens who are caring so much about the communities and the planet. So thank you.
And thank you, the 3 of you. Fantastic work that you did in this report. So let's give them a hand.